Okay, let's now have a look at what happens when we combine transformations. The key question I'd like to explore to start with is this. Suppose we apply two or more successive transformations to a graph. Does the order in which we apply those transformations affect the result? To explore this question, we're going to apply successive transformations to a single point, in this case 5, 2. So here are three transformations we can work with. A is a translation 4 units in the positive x direction. B is a stretch scale factor 3 in the x direction. And C is a stretch scale factor 6 in the y direction. First of all, we're going to start with 5, 2 and apply A followed by C. Then we're going to compare the result with what happens if we apply C followed by A. So starting at 5, 2, if we apply A, that's a translation 4 units in the positive x direction. That means the x coordinate will move right by 4. That gets us to 9, 2. Then we'll apply C, which is a stretch scale factor 6 in the y direction. The effect of that will be to multiply the y coordinate by 6. That gets us to 9, 12. Let's try reversing the order then. Starting with 5, 2, we first apply C, stretch scale factor 6 in the y direction. Multiply the y coordinate by 6. That gets us to 5, 12. Then we apply A, translation 4 units in the positive x direction. Add 4 to the x coordinate gives us 9, 12. So for this particular combination of transformations, the order did not affect the result. So maybe this topic's nice and easy. Maybe it never matters what order you apply the transformations in. Let's have a look at a different combination of transformations. This time we'll do A followed by B, and we'll compare it with B followed by A. Starting with 5, 2, we apply A, translation 4 units positive x direction, gets us to 9, 2. Then we'll apply B, stretch scale factor 3 in the x direction. Multiply the x coordinate by 3 gives us 27, 2. Let's reverse the order. Starting at 5, 2, apply a stretch scale factor 3 in the x direction, gets us from 5, 2 to 15, 2. Then we'll apply A, translation 4 units positive x direction, add 4 gives us 19, 2. Oh, so in this case it did matter which order we did them in. So we need to consider then, why did the order of the transformations we applied in part A not affect the result, but the order of the transformations we applied in part B did affect the result? So here are those transformations again. In the first sequence, where the order did not affect the result, we did a translation in the x direction, followed by a stretch in the y direction. In the second sequence, the order did affect the result. We did a translation in the x direction, followed by a stretch in the x direction. So I'd like you to pause the video and have a think just for a few seconds. Why in the first set did the order not affect the result, but in the second set it did? You don't have to write anything down, just form an opinion about why you think it happened. Okay, welcome back. Here's an opportunity to test whether what you thought was true. We have a different set of transformations and a different starting point. What I'd like you to do is pause the video, have a go at the transformations, then come back and check your answers against mine. Welcome back. Here are my answers for part A. In part A, if we apply A followed by C, we get 4, 8. But if we apply C followed by A, we get 4, 23. So for part A, the order did affect the result. Part B, if we apply B followed by C, we get 2, 28. And if we apply C followed by B, we also get 2, 28. So it didn't affect the result. Let's have a look in more detail at this example. So here it did affect the result. We did a translation in the y direction, followed by a stretch in the y direction. Notice that both transformations were applied in the same direction. In part B, we did B followed by C, stretch in the x direction, followed by a stretch in the y direction. Notice that they're applied in different directions. So at the beginning of your note sheet, you'll see there are 2 sentences inside the key facts box that aren't finished. When one vertical transformation is combined with one horizontal transformation, what happens? And when two horizontal transformations or two vertical transformations are combined, what happens then? I'd like you to try and fill it in your own words. If you're not confident about what you're writing, I'd still like you to try and write something, but do it in pencil, because then if you're not happy with your answer, you can rub it out later. So pause the video, write something down, and then come back and compare it with what I've written. Welcome back. Here is what I've said. When one vertical transformation is combined with one horizontal transformation, the order of the transformations does not affect the outcome. And when two horizontal transformations or two vertical transformations are combined, the order of the transformations may affect the outcome. Now notice here that I've used the word may in the second sentence. That's because there are instances where two horizontal transformations and two vertical transformations may be applied and the order doesn't affect the outcome. At this early stage in the topic, don't worry too much about that. The key thing that I want you to take away at the moment is if you apply one transformation in the x direction and the other in the y direction, the order doesn't matter. But when you apply two in the same direction, it does matter. Having said that, if you've got the time, feel free to have a think about situations where you might apply two horizontal or two vertical and the order does not matter.